Hello, welcome back. So yeah, we're back to you recognize that triangle. I know you recognize that triangle, and we are back. That's why we are here. So this is the last time I'm going to talk about this course because it's a teaser. It's not a spoiler. So you should, if you're interested, do the course yourself. It's can you guess how much it costs? It's whopping $0. It's free, so you can do the course yourself and learn more about security. There are all these like quiz because you can see at the end there is the quiz that you could do it yourself. You can check understanding. If you want to get certified, you can, but getting certified is not free. But all the materials are free. You can learn it for free, which is the thing that I really love. So I will be actually finishing this course by myself, but before that, we gotta do the chapter 3 together. So we still have one section in chapter 3 that we haven't done. So it's about because last time we talked about a lot of problems that we may have. We may have, some compromises in any of these triangle. We also have a lot of privacy law that if we are not careful, then if we have some risk to security, then we may have problems. We may leak data and violate these regulations. So we don't want that. We don't want that. We want to everything to be secure. So what can we do? So this chapter, I haven't read it. I also read it for the first time myself. But it will talk about a lot about, for example, risk management, how to identify the risk, and so because the first step to solve your problem is to identify the problem. That's I think that's quite straightforward. I hope so. Let's do it. So the need for risk management. So so like I just said, we need to identify those risks and manage them to minimize them. Right? There's nothing is perfect in this world. There's always risk in everything, but we have to manage them. So there need to be a way. So potential problems. So to develop a secure software is to manage the risk of developing insecure software. So to minimize the risk, to manage them, to rather than let them be whatever and grow and there's risk everywhere, we have to control them and manage them. They become problems. So we identify those risks and we try to prevent the problem happening. So that's how we can manage the risk. So so this is like, if people start using the software you develop, expect that in intelligence advisory will try to attack it. So just prepare for the worst, I guess. So do not wait to think about risk until they happened. Then they're no longer risk, they become the problem. So that's why you have to identify it yourself actively before sitting there and wait until become a problem. Then you would have a lot of headaches. So it may also there's a lot of consequences. Your professional reputation, software's reputation, and your organization's reputation could be risk. So we have to take this very seriously. Risk management process. Sorry, my monitor is like very weird. I'm adjusting my monitor, so angle is very weird. That's why I'm like, I don't know where to look at because I think at some point I was tidying up my desk and all the monitor moved, and now I feel very weird. Okay, so risk management process. So we have to have planning, determine your project's risk management process, and identification. Identify the potential problem before they become a problem. That's the key thing. Risk analysis, the likelihood of those undesirable events and the severity of the consequences. There are actually the different kind of level of vulnerability, right? There are high, there are severe ones and less severe ones. So understanding which one the risk belong is also very important. Risk handling, acceptance, avoidance, transfer, control. So accept. So once you kind of confirm that's the risk, accept that's the risk. Then communicate to stakeholders, including users. Reasonable if the severity is low. So if this is low, then so we can be more open and we can talk about that. Of course, if it's severe, then maybe you want to keep it a secret before, before you patch it. Avoidance. The risk is eliminated by making some changes. So fix the problem, patch it, prevent the vulnerability happening. Transfer. Risk is transferred to someone else. Buy insurance. That's not just software, but real life. If you rent a car or buy a car, you need insurance in case something bad happened. Changing the system so another component has that risk, and developer accepts it. This is very interesting as like one of the handling. We are not saying whether it's good or bad, but this is one of the way you can handle it is to transfer to someone else. So controlled, actively reduce the risk to an acceptable level. So this is kind of like fixing it, patching it, right? So interesting. I really love like transfer. None of my problem. That's now yours. Cool. But of course there need to be communication. If there needs to be a lot of communication whether that is a good move or not. Like so, risk monitoring. Determine how the risk have changed over time. So you need constant monitoring. So it won't just like, oh, we have fixed it, so it's fine. You still have to monitor it. See, whether it's because chances are you can't really like totally do any of these to solve the problem. Sometimes you accept it, so people know that there's a risk, and it's probably will be there for a while. So, or you can avoid it, but you can't avoid it completely. So monitoring it to see how things evolve is very important. So a lot of, for example, you have a service out there live, you have to monitor it all the time anyway, so it's always a good thing. So, identifying risk. So how can we do that? How do you identify the risk of security vulnerabilities? There's a story, but it's a bit long. I don't think I'm gonna read the whole story. Go read yourself. I don't mean that you pause the video. Go to the course, do it, and read it yourself. Checklist guidance tips help remind people to look for certain things. So it's always good to have a checklist when doing things. So your experience of what to look for can be passed on to other people as well. So having a checklist in projects is always a good thing. Another technique that helps is working to develop slightly paranoid mindset. Clinical level of paranoia. Everything needs to be like very rigid and make sure that like the surgeons, they have to wash their hand maybe multiple times, and they do this and don't touch anything after washing their hands. Like there's always a protocol of what things should be done to make sure it's safe. So that could be one thing. So there's a checklist, check it multiple times. Paranoia may be a good thing. So you can identify those risks. Security is a process, not a product. So interesting. So do we have something? Because like we have SaaS and things, so can we have a security as a product? So I don't know. Sorry about the bad joke. It's probably just me finding it funny. The world changes. The way your software used is changed. New vulnerabilities are discovered. The software's platform and library changes. So law, company policy, and goal also changes. So software that was secure a year or 5 years ago may not be adequate today. So again, you can't be like, okay, it's fixed, it's fine, everything is gonna be fine forever. No, there's no happily ever after. You have to keep on working. It's kind of like me, I have to keep on exercising, otherwise, it's like yeah, it's like health, you keep exercising, keep, being healthy. It needs to be maintained. So yeah, it's a process, not a product. You have to always constantly, working on it. Checklists are not security. So we just talk about, checklist is good, we can like kind of use it to identify risk, but having a checklist is useful, but it doesn't mean that it's secure. Having a checklist doesn't mean that it's secure. Good checklists, guidelines, and tips can save you a lot of time and trouble. They're great for aids to help others evaluate the security of some software, but they're only aids to the real goal. So they are a good tool, but they are not, having them are not, doesn't mean that, okay, it's secure, it's fine, because there needs to be action. There's no substitute for thinking. This course will give you a number of tips to help you to reduce risk. Focusing on lessons that previous developers have learned, but they are merely tips. They're merely an aid to develop secure software. So when you are developing software, continuously think about the way that an attacker may try to exploit your system. So it's always this like cat and mouse game, right? There's like there are people who exploit the system, who are hacking. They may be, with good intention, they may be able to help you find vulnerability. Then you make it more secure. So it's always this cat and mouse game to make things more secure. So yeah, again, this like nothing is perfect. It's always evolving. So you have to keep on, it's like on a treadmill. You have to keep running. So yeah, using checklists are good, but just having a checklist are not enough. It can help you. It's a good tool, but to get there, you have to put action on it. You have to think for yourself. So this is what it's talking about. So test my understanding. So shall I test it? So the quiz are not supposed to be shown, but this says start quiz, but it's just test your thinking. I think I won't say this is a quiz. I will say this thing at the end are quizzes. So I think it's okay to show this, but not the one at the end. So let's see. The purpose of developing secure software is to eliminate all possible security risk. Yes, because like I said, there's no perfect solution. You have to keep on working on it. You can't just be lazy, right? Okay. So by the way, this is actually how a quiz will look like. So I show you how a little bit the quiz will look, but not the quiz itself. Of course, you have more than one questions. So yeah, you can at the end you check it. You can of course retake, but you can also review to see which one is right, which one is wrong, and how you can learn from your mistakes. Yeah, that's how the quiz looks like, but we are not actually doing the quiz. Well, this is a big chapter. We have to speed up. I'm talking too much. Okay, development process and defense in breadth. Individual software development and development process. So there are some tips, and this is a checklist and tips. Is again not not the one send for all solution, but it will give you some knowledge and ability to do it yourself. So what does it mean by defense in breadth? Whenever you develop software, there's a certain process that all developers have to do, including determine requirements. For example, for security, make sure you know what security requirements it needs to provide. For example, is that data should keep confidential. Okay, so what are the requirements? Determined architectural design. So how to divide up the problem into interacting components to solve it. Yeah, so everything is a unit. Later in this course, we'll discuss various secure design principles to help you design a system that is easy to secure. So that would be on you. If you want to find out, do the course. Select reusable component. So decide what reusable package and library you will use. You need to evaluate the component you will use, since any of these vulnerability may become vulnerability of the software you are developing. Supply chain security. So yeah, you have to make sure that the component you're using, probably another library, is safe. This reused component come from somewhere, depend transitively on other components. The set of all those dependencies, including where they came from and how they eventually get to you, is your supply chain security. We always talk about supply chain security. That's why it's important, because if one component is super popular, if it's compromised, then everybody is compromised. That's scary. So that's why it's so important. Okay, implement it, write the code. Most security vulnerability made during implementation are specifically common kinds. Once you know what they are, you can avoid them. So while writing the code, make good practices. Don't do anything insecure, like accessing memory that you are not supposed to accessing. I'm still in like Rust mode. It's RustConf when I'm like, I'm so gutted. There's like workshop that I want to do, but it's not online, so I'm at home, so I can't. I can only watch some talks online, but I can't do the workshop. I feel a bit sad. Maybe next year I should go in person. Okay, verify it. Write implement tests and use analyzer to gain confidence that it does what it is supposed to. You should be testing to make sure that your system is secure and using tools to help you find vulnerability before attackers find them. So it's just like writing tests. Find the bugs before your user find them. Find the vulnerability before the attackers find them. Right? Deploy it. You should help ensure that user can get the correct version. That it is secure by default and what they can easily operate it in a secure way. So good versioning is also very important, because it's kind of also related to the supply chain security. Always pin the version, if that version is reported. So when there's the problem, someone can report that version has a problem, and if it got patched, then we have a different version number and people know that it's patched in that version. So that's also very useful in communicating all these vulnerabilities. Okay, next. Development, again, this is continuous of the last page, using these processes together. So common mistake is trying to execute these software development process in strict sequence. Figure out the requirement, then work out the entire design, and implement, then verified. Attempting to create software in this strict sequence is called waterfall model. The waterfall model is beginning. As you can see, I'm not an English native speaker. Like sometimes I come across words that I haven't seen before. That's okay. Doing this process in strict sequence appears rigid and sensible at first. In 1970, Winston W. Royce explained it in his essay. Wow, that's very, you can read the essay if you want. Why trying to follow these process in a strict sequence is extremely risky in most circumstances and should normally be avoided. So we have learned all those processes, and now it's telling you to not follow them religiously. Another common mistake is to implement software components independently and never integrate and test them together. Integration tests until everything is completed independently. This is typically a mistake because this leads to serious problem getting the component to work together. You can't omit integration tests. It should be there in the first place. In practice, most software development execute this process in parallel, bouncing information between the process and new information is learned. So for example, like you're developing the software, you're not writing the test at the end. So if you follow this structure, right, you implement it, implement before you verify. So you will be writing all the code before you test it, which is a lot of you who have written a considerable amount of code know that this may not be the best approach, because when you are writing the test, you will be feeling very you know, there's a big chunk of work that you have to do. You know, I think, yeah, now a lot of approach. I'm not saying like TDD need to be followed like again rigidly. Like anything follow them very rigidly is not good. So, but you know, kind of you have to test while you develop. I think that's the general idea. You know, when the component is done, you can test the component. Then you can, you know, run everything in integration tests before you deploy it. Need to be there all the time. So continuous integration. So it's to get stepping into CI/CD scenario here. So yeah, so this is talking about what is realistic is to do things in parallel. So also there's other factors: size of team, how reliable the result need to be. Also agile, waterfall development. So these are all like development processes that there's different people use different ways of managing it. But again, like yeah, sometimes depends on the team. Yeah. Okay. So highly recommended is to use continuous integration. Yay, we love those. You can see why, you know, GitHub Action is so popular. The practice of frequent merging working copies of development into a share mainline. So once every few days through many times a day, this routine merges reduce the risk of component not working together if integration was delayed until later. That's a good thing. However, successful CI requires a way to determine if components are actually working together. So you need to have a CI pipeline, a process that runs whatever something is merged to make sure. So, yep, GitHub Action, run all the tests, run the integration test, run if it will fail, if you deploy it before you deploy it. Many organizations want to deploy software so surface more rapidly and have adopted various approach. Continuous delivery aims to ensure an application always at production ready state after successfully passing automated tests and quality checks. Yeah, we have you know, some open source project. Well, I would say a lot of them are CI/CD. They may have their release cycle, but I do have worked on some that whenever things got merged, they would get a new release. So the numbers are quite huge. The number of versioning is quite huge. But yeah, they have their philosophy like this. Want to have a continuous delivery. There's also continuous deployment. Also CD, same acronym. Yeah, automatically continuously deploy application. So similar concept. DevOps. I'm not a DevOps professional, but yeah. So this is usually people who overlook the CI/CD process and stuff. There's also DevSecOps now, or SetDevOps, which is DevOps but integrating security concerns. So it's DevOps with security concerns. GitOps is a way of implementing continuous development for cloud native application, focus on a developer-centric experience when operating infrastructure by using tools developers are already familiar with, like GitHub Action, Git, and a continuous development tool, maybe GitHub Action. The core idea of GitOps is having a Git repository that always contains a declarative description of the infrastructure currently desired in the production environment and an automated process to make production environment matches the desired state in the repository. I'm not going to read the rest. Okay, so this is like very Git focused DevOps. Is GitOps. Okay, all these depends on automated tests and quality checks. I'm gonna skip over, but so I think it's quite useful to have a CI/CD pipeline that have some security checks there as well. Consider security throughout the development. It's not enough, but it's a good way to have it there. Okay, this is taking up a lot of time. Test my understanding. I hope I get it right. Develop secure software. You should always rigorously develop all the. No, we just say it's not true. Simply add security tool into your continuous. That's not enough. Yeah, so this is 2 questions this time. Okay. Yay, correct. Okay, moved on. This is another interactive. I love the fact that there's so many interactive things here, which is fun. Like the text wall that we just came across is a bit tiresome. Software is developed to be used, so let's briefly look at security from the viewpoint of operations. Click. Oh, this is just clicking, okay. It's like I've flipped a card like in the kindergartens or something. Identify. Develop an organizational understanding to manage cybersecurity risk, protect, develop and implement approaches safeguard to ensure delivery. Development and implement appropriate activities to identify the occurrence of cybersecurity event. Response. Activity to take action. So this is about action. What detect the cyber instance. Recover. So to like recover from the instance. So you go from like identifying to protecting to detecting, and then we have to take action and then recover from it. Okay. What is it? Response won't matter. I think you need everything, right? Yes. Oh, okay. Why are you asking? Oh, okay. I was like, why is it more and more question now? Okay, vulnerabilities is simply a failure to meet some security requirements. Typically, vulnerabilities are unintentional, but vulnerabilities can be intentional. For example, someone may have intentionally insert malicious code. So, yep, or at least attempt to do so in software you reuse or develop, such as a backdoor or a logic bomb. These courses and professional certificate program focus straightly on software, though of course hardware can also be have vulnerabilities. Modern society depends on software and hardware. As a result, there have been a massive growth in number of publicly known vulnerabilities. When we have software, we have vulnerabilities. This has made it difficult to answer simple questions like, did you fix this particular vulnerability? Okay, what should we do with vulnerabilities? Reporting and handling vulnerabilities. So there are people who find the vulnerabilities, who found security vulnerabilities in software. Security researchers. So they found those vulnerabilities. So they reported to the software supplier through a timed condition disclosure process. They find the privacy report. So first of all, they don't announce it. They would privately tell the supplier. So kind of like, hey, you got spinach in your teeth, right? To fix the vulnerability after this embargo time. So usually there is like a time frame as well, 14 to 90 days. When the vulnerability have been fixed, and user have an opportunity to install the upgrade version of the software. The vulnerability is publicly disclosed. So now you can see there's 2 scenario, right? So like it's either okay, the happy path, So hey, you got this vulnerability. Please, be aware. So they got patched. So user got update. Everything is safe. Yay, happy ending. But what if the supplier doesn't do anything? So after a time, then this will be announced. So everybody know that this software has a vulnerability. So users would have the option to not use this software. So things are more complicated. When there are multiple suppliers and other stakeholders, critically important to prepare ahead of time so that people can easily report vulnerabilities to you, so you can privately discuss the issue with trusted parties, and so that you can rapidly fix any issues. Professional certificate program further discuss how to accept and report vulnerabilities. So reporting is also very important, right? We want it to be quick. We want it to have a communication, like way of communication between party that got involved, and to overcome the problem before this time run out, and then everybody know that you have a vulnerability that you haven't fixed, which is bad. So how can we easily, provide this channel so these researchers can actually help you to fix your problem? So there is, for example, some tracking method use is common vulnerability and exposure. So you may have heard of CVE numbers. So this is this is the thing that is kind of like a protocol that is commonly used. So we would have a look at that now. So CVE, what are they? It's a global dictionary of some publicly disclosed cybersecurity vulnerabilities. The goal of CVE is to make it easier to share data with about vulnerabilities. A CVE entry has an identification number, so they will have an ID, description, and at least one public reference. CVE IDs have some form, so it will usually look like that, right? CVE dash year dash number. Year is the year that it was reported. Number is just a private integer, positive integer, so that they are unique. For example, CVE 2014-0160. Specific vulnerability in OpenSSL that was first reported in 2014. So there are also databases who store these informations. For example, there's like US National Vulnerability Database. So CVEs are assigned by a CNA. So there's an authority behind. So CNA is simply an organization authorized to assign CVE IDs to vulnerabilities affecting products within some scope defined in advance. The primary CNA can assign a CVE even no one else can. Yeah. Many CNAs are software products developers who assign CVE numbers for their own products. There are also third-party coordinators for vulnerabilities, such as the Search Coordination Center, who are CNAs. Each CNA is given a block of integers that can be used in CVEs, which means that CVE 2025 50,000 does not mean that it's a vulnerability number 50,000 in the year 2025, but merely the CNA who was assigned that CVE ID was authorized. So all these ID at the end, they are not canonical. It's just some people given that number to use. Python also have the now also Python Software Foundation is also now CNA. So recently, yay! Okay. Many publicly known vulnerabilities do not have CVE assignments. First of all, CVEs are only assigned if someone requests an assignment from the CNA. If no request is made, there will be no CVE, which could be not as good. In addition, CVEs are intentionally limited in scope. CVEs are only granted for software that has been publicly released. So yeah, also, it's not like, oh, I want a CVE, you will get a CVE. Also, it needs to be something that matters, then you will have CVE. CVEs are generally not assigned to custom build software that is not distributed. So if they're not publicly used, then they don't have a CVE. They are also not normally assigned to online services. That said, CVEs are most widely used method of giving a unique number identifier for each publicly known vulnerabilities. It's important to know them. So top 10. Wow, it's raining heavily outside. I don't know if you can hear it. So top vulnerabilities. I just talked with my colleague the other day that we love top 10s, right? It's always, go to YouTube, you see a lot of top 10 tourist destination, whatever, top 10 food. There's always top 10. So we also have vulnerability top 10s. So there are lots of organizations who are doing some research about, the most common problems that people may have, just to warn developers and users what challenge they may commonly face. So there's a CWE as well. So CWE is common weakness enumerations. So the difference between CVE and CWE is CWE identify a type of vulnerability. CVE identify a specific vulnerability that was found in of a particular product. So CWE has an identifier and a number. We will also talk about CWE, but CWE is a huge list and we cannot cover all the CWE. So if you're interested, there are the famous ones, for example, OWASP top 10, So this focusing on web application, so open web application security projects. So for example, they will have the top 10 API security risk, so you can check that out to make sure that you are more aware of those. There's also CWE top 25 list as well. There's a common weakness enumeration. So yeah, so this also like this not just top 10 to top 25. It's a long list. It will take a while to cover all of them. So OWASP also have other lists. There is also mobile top 10, Internet of Things top 10. So everything got a top 10. So OWASP really did a lot of work in discovering them. So yeah. So yeah, check those out if you're interested and learn more about what kind of vulnerabilities are on the top. Yeah, so a lot of them actually is in this course. Again, if you want to learn about them, please subscribe. No, please not subscribe to me, but subscribe to this course. You go and do the course yourself. Yeah, it's you can find this course either on the Linux Foundation. You can actually, there's the link in the description. It should be. I'm pointing at it right now. Or you can find it on the Linux Foundation courses catalog, or you can also go to the OpenSSF website to find it. I spent a lot of time throughout this course reviewing different type of vulnerabilities. The risk of doing this is that you may think that all is there, but it's not true. So we are just covering the most common ones, but there are more out there as well. Depending on how you measure the things, anywhere from 90 to 99% of or more vulnerability will be covered in the top list, which is covered in this course. By preventing these common mistakes, you will reduce the number of vulnerability by at least an order of magnitude. So again, there's always nothing is perfect. You just have to keep running on the treadmill, but this is helping you to run faster. Run faster than many people. So this will by doing the course, you would understand the most common problems. Then you can learn how to avoid them. Now you have tools in your tool belt. You can do that. You'll be smarter than before you do the course. So I highly recommend you to do that. So let's do the final. No, actually, I won't go. I'm not going to show you this final test. I will make it a secret, and also the other ones as well. So I guess this is where we part ways. Again, like this course give you a lot of tools that can help you, so you can be smarter. There's a lot of things. If you look at the left hand side here on top of my head, you see there's like a lot of topics. It's going to be covered in the course, so that's why I'm not going to read all of them. I think it's better if you do it yourself. So go do it yourself, and I'll be really happy. So there's also a forum there as well. Hopefully to see you there. Hopefully you'll be smarter than me. I always say that people I give talks or give workshops, and usually people are smarter than me. I don't know why. I just give people some tools that they could use. That's what I've been doing. So thank you so much for came on board on this journey with me. So that's again, like, this is where we part ways. So chapter 1 to 3 we have to go through, but there's like more than 12 chapters, so we're only less than 1/4 of the way there. So have a safe journey going through the course, and thank you so much. Next time I will do something different. I don't know yet, but if you follow me, you know what I'm gonna do next. Also follow OpenSSF YouTube channel as well. There will be more video coming out. There will be various different things, not just me. So yeah, I will see all of you in the future. Yeah. Bye.